Hey there, everybody. Welcome to the Daily Space Weather. The first thing we're looking at is the sun, which is going to murder us today. It's all covered with carbon. Look how scary that is. Oh my God, it's 1600 angstroms. 1600 angstroms, a wavelength of ultraviolet light, showing us a bunch of carbon down in the chromosphere, which means the sun is shutting down and it's going to simultaneously kill us. Just kidding, folks. That's complete and total nonsense propagated by fraud grifters on YouTube, not by this channel. So here's the sun in 1600 angstroms, and we're just showing this view to show you the exotic chemistry that goes on the surface of the sun, in the corona, and more. Here's another view. This is ionized iron, 335 angstroms. The cool blue tones are showing a different portion of the chromosphere and a different portion of the solar corona. There are 3 named sunspot groups at the moment. Some umbrae briefly appeared yesterday that almost got named right up here. You see that little magnetic appearance there? Right there. There were some umbrae associated with that briefly yesterday, and those quickly evaporated. So there's the colorized magnetogram. All the Earth-facing sunspot, both of the Earth-facing sunspot groups here, both of these here, have degraded over the past 24 hours. We've got some more exotic views here. This is 94 and 1700 angstroms. You can see the dark umbrae of those sunspots there, as well as ionized iron. Higher up in the corona, shown in green. It's 94 and 1700 angstroms. 2 different specific, very specific bands of the ultraviolet electromagnetic spectrum of light. The radio flux has dropped down to 88 as those sunspots degrade. That's not particularly surprising. Here's a one-year chart to put it in context. The black line here is the sunspot number. Is the radio flux. The red line is a sunspot number. The 10.7 centimeter radio flux is the most proportional data set to sunspot number. Hence, it's kind of important in evaluating solar cycles. Here's a space weather enthusiast dashboard showing us 0 space weather forecasts for the next 3 days from NOAA. We have seen the BZ dip into negative territory. We'll get to that momentarily. First, some seismicity. We've seen a couple of 6+ magnitude earthquakes here in the past 24. So the largest of the past 24 was this 6.6 at Hirara, Japan. And we don't expect to see any tsunamis from that. I checked. No tsunamis expected from that quake. I know it's a little bit late to be talking about it at this point, nearly 24 hours later. There was also a 6.0 at Indonesia, and that one occurred 61 minutes after the Japanese 6.6. So there you go, 2 quakes, barely an hour apart, pretty close to the same portion of the Western Pacific there. Besides that, there was a mid-Atlantic ridge quake, as you can see there in the North Atlantic Ocean. Some Aleutian Islands quakes, one in the Bering Sea, one in the Pacific Ocean there, south of the Alaskan Peninsula. So a little bit of an uptick there in seismicity, although the 7 magnitude earthquake drought continues. Let's hope none of those were foreshocks. A larger quake could indeed cause tsunamis or additional damage, like structural damage. Let's take a look at Volcanoes Today on the volcanodiscovery.com Volcanoes Today page. And La Palma is a perfect example of a caldera not to pole vault. It continues to erupt. It's still producing an 8,000-foot plume of volcanic ash, which means it's been pretty steadily erupting since yesterday. Watch yesterday's video to see a little clip about that, the lava flowing into the ocean there. By the way, that's pretty far away. That's a massive lava flow, and there's a bit of a perspective shift in that image that may make it a little unclear as to how huge that flow of lava is. It's quite large. I'll just leave it at that. Karimsky may be erupting. We're not sure. Volcanic ash not identifiable in satellite imagery at Kamchatka. So Kilauea, activity at the Halema-Uma'u lava lake has picked up again since about the 4th of November. So about a week of upticked activity there on the big island of Hawaii, the southern portion of it. The Kilauea Halema-Uma'u lava lake. Fuego exploding, producing a 15,000-foot ash plume over Guatemala. Nevado del Ruiz exploding, 22,000-foot ash plume over Colombia. I'd like to check out all of these volcanoes. My bucket list grows and grows. Revenador is exploding, 15,000-foot ash plume over Ecuador. An incredibly beautiful, if not a bit dangerous country, Sabancaya exploding as well. 24,000-foot plume of volcanic ash produced from the Sabancaya volcano. Our reminder to visit our links and not pole vault the caldera. Don't forget to use the promo code YWAIT on any checkouts to save 20 to 60% on orders store-wide. So why wait to pick up holiday gifts? These make great holiday gifts, by the way. Public service messages galore. Mensa, make Earth not suck again. My vaccination status is none of your business. Do not pole vault the caldera. What about the definition of the word fraud? An intentional misrepresentation of material facts. How about make America not suck again? How about universum liberate? Check out the store. Again, promo code YWAIT to save 20 to 60%. You can find links at smashamash.com. Just click smAsho merch. Perhaps support the channel with some holiday gifts for your friends, foes, science noobs, and science pros. There's somebody to make everybody mad at our store, so pick something up. We come from the tradition of stores like Spencer Gifts. Next, some magnetic data. First, the GOES 16 and GOES 17 magnetometers. There's the past 3 days from them. Just seeing pretty smooth curves here as Earth is solidly in a South Pole current sheet last I checked. Let's check again. So indeed, you can see Earth here in a South Pole current sheet shown in red. No expected changes coming anytime soon. Keep in mind the magnetic environment can suddenly change with basically no warning. Here's a line of sight plot of the same data. Again, all those sunspots have been degrading over the past 24. Here's your line of sight coronal hole plot, which is probably the most important data set to look at when evaluating the progression of a solar cycle and a solar polar field reversal. And we've got some coronal holes rotating in once again here in the southeast. They've actually shrunk in the past couple days. We do see some definition there. And here's the last day in 193 angstroms from the SDO, the Solar Dynamics Observatory. You can see that coronal hole gaining some definition. Keep in mind, folks, coronal holes are sometimes hidden from our view. The magnetic data shows them better because the solar corona is very bumpy. In other words, plasma in the corona can obscure coronal holes. It can't hide from the magnetic data. Continuing on to look at the coronal mass ejections that have occurred in the past 24. Don't worry, they're not Earth-directed. And by the way, if you're wondering, the sun's not going to kill you. So here are the views from Lagrangian point 5, where stereo A is located, as well as Lagrangian point 1, where the LASCO C3 is located. That's not the right data at all. And I had some tabs out of order there. We'll get back to the coronal mass ejections momentarily. First, the detected sunspot groups and solar flare probability. Flare probability has dropped since yesterday. Detected sunspot groups have become less complex, less likely to produce major flares. The most likely place to see a major flare is remaining here at sunspot 2895 there. That's the most likely place to see a major major flare, as it is the only magnetically complex sunspot on the solar disk. Here's the X-ray flux over the past 3 days. You can see that M-class solar flare occurring on the 9th. It's 11/11, an elemental day, as there are 4 ones in the date 11/11, which makes it an elemental day because there are 4 elements. I don't know. I'm just doing some meteorology to freak out all of you numerology nerds. All of you OCD people who are obsessed with numerology, chill out. Here's the proton flux over the past 3 days, and you can see the slow subsiding of that proton strike. That was associated with this coronal mass ejection, by the way. It took about 4 hours for those semi-relativistic protons to show up. They've since subsided. How about the real-time solar wind? And there you have that. Current conditions are... First remark is the BTBZ, this top pane. It's measuring the total field as well as the orientation of the field to one of the solar poles. We've seen the BZ drop into negative territory here. So we may see geoaffectivity come up a little bit. The KP index may rise as a result of this. Also, there's been a recent small uptick in the solar wind density. So a negative BZ is more conducive to induced currents from incoming solar plasma. That's something. Solar wind density, currently just under 12 protons per cubic centimeter. Solar wind speed, just under 400 kilometers per second at 387, as reported by real-time solar wind. KP index is currently at 1. Again, we may see this rise to like 2 or something. If the BZ continues to shift negatively, it's not really anything to really be concerned with. Next, 4 hours of data of magnetohydrodynamic pressure. It's the Space Weather Modeling Framework Geospace Magnetosphere movie. We show it daily on the channel, so you can see 4 hours of data. If you're concerned in the last 3 or 4 years, what's been going on with this, around this time of day, go watch our earlier space weather videos. We're pushing 900 just on the playlist and pushing 4 years of doing daily space weather videos. I think we've missed 1 day over that entire period. Next 4 hours of ground magnetic perturbations here. Since there's a polar excursion going on, we're showing you the changes at the ground level to Earth's magnetic field, Earth's B field. And we see some equatorial pulses happening once again here around places like Southeast Asia. I'm going to let it play through a second time, folks. Geospace delta B would be changes to Earth's B field. And the scale you're looking at here is 0 to 400 nanotesla, which is magnetic flux density. The last geospace magnetosphere movie we showed you was magnetohydrodynamic pressure. Again, this is the ground level magnetic perturbations of planet Earth. Next, we want you to be oriented. And so we show a solar system diagram every day. Keep in mind, this is not to scale. If you want to see what it looks like to scale, you can click on that, and you can see it's planets are far apart. Let's just put it that way. I usually use the diagrammatic view because it's the most visually pleasant. Here's your 1-week forecast for the solar system. Mercury making a pass to swing in between Mars and the Sun, which will cause absolutely nothing to happen on either planet or the Sun. Next, looking at a star chart, we've got, I think, Mars and Mercury are rising here ahead of the rising sun in Lehigh Valley, Pennsylvania. My star chart is facing the south. The yellow line is the ecliptic. The blue line is the galactic plane. And now we're going to look at stereo A and the LASCO C3. Stereo A is located at Lagrange point 5, which puts Earth off to its right from its perspective. Lagrange point 1 is the location of the LASCO C3. That's the blue frame here on the right side. The red frame on the left side is the stereo A coronagraph. And since we saw a coronal mass ejection, this one's going to miss Earth to the west, it looks like, by all reasonable accounts. Another decent solar flare showing up to add to the visual imagery on today's daily space weather video. Let's do a brief cosmology segment. We're going to look at cosmic ray flux, which at Apatity is slightly down over the past 30 days on the average. Barentsburg, also slightly down on the average over the past 30 days. Let's go farther south to Athens, Greece. And there is the Athens neutron monitor. You can see a bit of a downward trend there over the past 30 days as well. How about Mexico City? Going even farther south here. Downward trend at Mexico City over the past 30 days. No surprises as the solar cycle ramps up. And here are 3 more reasonable cosmic ray monitors. These are carefully curated to not include crappy data. Here is the Oulu neutron monitor. You can see a downward trend over the past 30 days at Oulu, and 2 in Antarctica. So there's DOMB Antarctica. Downward trend there over the past 30 days, and a downward trend at DOMC Antarctica. Probably no surprise there to our regular viewers. Today's random number is not being picked at all. We're looking at Cygnus X1. Yesterday, our cosmology segment included information about the Large Magellanic Cloud massive radio source known as LMC X1. Today, we're looking at the first object widely believed by, quote, astronomers and, quote, to be a black hole. It's a high-mass X-ray binary, certainly a massive radio and X-ray source. Cygnus X1. Anyway, this is at an infrared light. And if you zoom out, it's a pretty busy part close to the galactic plane there. Anyway, there are the thermal emissions from Cygnus X1. And here it is an optical. This was famously bet on by Stephen Hawking and Carl Sagan back in the late 70s or early 80s on whether or not it is a black hole. So in any case, these are the X-ray emissions from Cygnus X1. And we're going to shift things to NGC 1333. You'll understand why in a moment. So here's NGC 1333 from the New General Catalog. This is the multicolor, false color X-ray imagery from the XMM Newton. So that's X-ray right there. And we're going to show you this in infrared as well, as there are some interesting features that we're going to show you more of. So there's NGC 1333 from the New General Catalog. And the reason we're showing you that today at the CDS portal is because the astronomy picture of the day is composite imagery, which is a little bit better than what we just showed, at apod.nasa.gov. So there you go. NGC 1333 is the astronomy picture of the day from NASA. Just fantastic imagery there. Multiple different wavelengths happening here. That's probably Chandra X-ray imagery, the way it looks. There is a Herbig-Haro object involved and so on, which is a sort of a naughty star with big obvious plasma jets and so on. So perhaps have a read about that if you like at apod.nasa.gov. That's today's cosmology segment. It was integrated into the Daily Space Weather video. We've got a playlist for cosmology segments at youtube.com/smashamash/playlists. Next, looking at charging hazards. We don't see any at the moment. Electron flux has dipped a bit here into more moderate levels. There's the one-year chart of that. To put it in context, here's the 3-day chart of the electron flux as measured by the GOES 16 and 17. So a little bit of a subsiding there of the high levels of electron flux. Just made it into warning levels for a brief period yesterday. No big deal. Here's the forecast for flat levels today and flat levels going into tomorrow, rather. And then a small dip according to the NOAA forecast. I have no reason to argue with that. Next, a diagram of the Van Allen belts, because we're going to show you the total electron content forecast. Your GPS may have to communicate with you through a lot of electrons. Most of them occur around the equator at noon, but sometimes we get chaos happening, like what's happening around Madagascar and around North America. We're getting some anomalous GPS likelihoods there. Expect some GPS errors. Like early in the morning in North America and so on, at some unexpected times this far north. Yeah, indeed, we'll see some GPS errors over where I'm located, which is in Lehigh Valley, Pennsylvania, if you weren't aware. Next, another diagram of the atmosphere to show you where the F layer is. It's the F layer of the ionosphere, which in many ways is the bridge between Earth and space. And we've got some anomalies happening here, which are jumping right out at me. If you don't view this data every day by watching our videos every day, you might not understand what you're looking at here. What you're looking at is vibrational frequency of atmospheric molecules. The ionosphere, there's a lot of action going on up there. And each color blob here represents 1 megahertz or 1 million extra vibrations per second compared to the neighboring colors. Anyway, there are a bunch of anomalies happening here. I won't try to explain them. There's the latest image from 11:15. Here's the anomalygram to show you anomaly in megahertz from the 30-day median. And you see quite a lot of anomalies here happening. In various different portions of the world. If you're new to the channel, the red portions are the low-frequency anomalies. The blue portions are the high-frequency anomalies. And we use blue and red that way because of things like Doppler shift. As light gets shifted toward the blue if the light source is moving toward you at a very high speed, and light gets shifted toward the red if it's moving away from you at a very high speed. That's why they use those colors for the high and low frequency anomalies. Anyway, it's called the Doppler effect. And there's the current image, and you can see some anomalies happening here right around the Middle East and East Africa. There's the 1115 ionogram, and there's the 1115 universal time anomalygram. All right, here come bonus features. We did our meteorology segment. It premiered before this video. Let's take a look at what's going on over India. The Udaipur, India ground-based solar observatory looking at hydrogen alpha. Degrading sunspots. Likelihood of solar flares has dropped since yesterday. Here's your latest intensity gram to show you, again, degrading sunspots. Here's the latest magnetogram. We'll get back to that in a minute after it loads. 2895 is breaking down. It's still the most likely spot to produce major flares. There may be some additional umbrae developing behind this, so this could actually increase the likelihood of solar flares from that. Otherwise, not a lot going on. Yeah, you know what? This has increased the likelihood of solar flares. This has decreased the likelihood of solar flares. We may even see a North Pole current sheet showing up as a result of all of that. Here's the NASA GOES 16 SUVI imagery in ionized helium, 304 angstroms. Fairly decent sized filament over here in the western limb. We've got some more spectacular SDO imagery for you here. It's the 171 angstroms. 1 day video there. That's 1 day of solar activity. Here's 304 angstroms. So maybe a little uptick here in this southern sunspot. We'll be keeping an eye on it. And when I say ion, pardon the pun. So we showed you 171. We showed you 304. And now we're going to show you the composite. And we're going to close out the video. We've got a lot of stuff to do today. And we're sure you do too. So thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, and may that solar wind be at your back.